right, 6.1 polygons. All right, so what I'm going to tell you is I'm going to do my best to draw the pictures for you as we're going over stuff, because otherwise it's really hard for you to do them. But for this section and possibly the next section, I will make an exception that you don't have to copy the picture out if you want to, so that you have it for reference. That's fine, but just because some of them are kind of hard to draw and them look like even remotely right, I won't make you copy them over. That will be optional for this section. So the first one said to just decide whether the figure is a polygon or not, and if it is not, explain why. So number 4. Looks something like that. So it's a polygon if it has obviously all straight sides, they are all connected, and they only have, like, each side only intersects 2 other sides. So is this a polygon? Yep. Is this a polygon? Why? Yep. So if there's a hole or a gap or whatever doesn't connect, it can't be a polygon. The official mathematical reason would be that 2 sides only intersect 1 other side, but, you know, if you said it doesn't connect, that would be sufficient. Tell whether the polygon is equiangular, equilateral, regular, or none of these. All right, so would this one be equilateral, equiangular, regular, or none of the above? Yep, none of the above. Because while we have 4 sides that are congruent, only 2 are congruent to each other, and then we only know about 1 of the sets of angles. Regular is equiangular and equilateral together. And we'll have more examples of these. These are just kind of the intro problems, and then there'll be a few more examples a little bit later on as well. 10, we're going to be solving for the measure of angle A. Do what? How did you get that? Yep, so to find A, we do 360 minus all the other ones, so 125 minus 60 minus 70, and it is 105 degrees. All right, again, we're back to deciding if it's a polygon or not. It's my iPad's time to shine. There we go.
What the? Yeah.
Waited however many years to be able to actually use this in class. Is this a polygon?
That was kind of cool about it.
Yes, this is a polygon. Each side intersects only two other sides. They all intersect to form it. And there's no curved sides. 14. Is this a polygon? Nope. Obviously, it is a circle, which has no sides. Or an infinite amount of sides, depending on how you want to think about it. 16. Is this square a polygon? Yes.
Yeah, this homework looking easy.
Hopefully. All right, now we're getting into concave or convex, and they also want us to state how or what the name of the shape would be based on how many sides it has. I'm gonna do my best. 18. All right, so what shape is this based on the number of sides? It's a pentagon. It has 5 sides. And then we want to know if this is concave or convex. So it's concave if any of the sides, when I extend them, extend into the actual shape. So is this concave or convex? Yep, convex. 20. What is happening? Doesn't like me, apparently. We're just going to make that side be a little crooked. Because it's not wanting to draw correctly.
Is it supposed to be like slanty like that?
Kinda.
Does it really look like the
It doesn't look like the one in the book, but it's fine. It's close enough. It has the same number of sides, I think.
I'm telling you, bro, that star was deep, bro.
1, 2, 3, 4, 5, 6, 7. Okay. All right. So what kind of shape is this? Has 7 sides. What?
No. Hexagon.
Hexagon is 6.
Size.
Hep-
It's 7.
Heptagon.
That's why you're both thinking.
And then is this concave or convex? Concave, because if I extended these sides, it extends down into the shape. So that makes it concave. Get rid of my dots. Okay. But this right here is why I told you you don't have to copy them out of the book. Because then it probably won't even look like the book. All right. State whether the polygon is best described as equilateral, equiangular, regular, or none of these. Okay, this is where markings are going to be really important. It's supposed to be a heptagon. This is why I said this is not art class. It doesn't have to be pretty. Miss Dutcher probably cares if you're pretty, or if it's pretty. I do not. I'm not good at art.
Yeah, I couldn't even do better than that.
All right, so is this equilateral, equiangular, regular, which means it has to be both of those previous things, or is it neither of them?
Regular.
Regular.
It should just be called both.
Let's see if I can do a little better on this next one.
This is why stick figures and this pair angle.
Well. All right, it's a little better. This one's kind of supposed to look like this. All right. Equilateral, equiangular, regular, or neither?
Equiangular.
Equiangular. All right, jumping a little bit. Now we're actually going to be solving for the values. 38. I just put these letters in the wrong place. Just Andy. A, D. There we go. All right, so we're solving for angle A. So how would I set this up to solve it?
Angle A. Oh, shoot, 360 minus 124 minus 110 minus 55.
Yep. And when I do that, that ends up being 71 degrees.
Do we have to put the angle A equal before we solve it?
No, I'm just doing that because on some of them there's going to be multiple things that you're solving for potentially, so I just did it just to specify, but this one just asks you to solve for A, so it doesn't really matter. Use the information to solve for X. So this one is going to be a little bit more involved. 42. We're just going to draw it a little sideways. It's fine. All right, so I've got 60 degrees, 150 degrees, 3x, and then over here, this one, they just put the right angle symbol, so I know that that's how many degrees.
90.
It's running away. 90 degrees. So I need to solve for x. Any ideas on how I might set this one up?
3x equal to. No?
90 plus 60 plus 150, and then add all that minus 360. Oh, you're saying 3x.
Divided by 3x.
Yeah, but like whatever.
How about we add them all up and set it equal to 360? 3x plus 150 plus 60 plus 90 equals 360. So then this is 3x plus 210, 300 equals 360. Then subtract 300.
20, isn't it?
So 3x equals 60. Divide by 3, so x equals 20. One more. $44. I'm going to draw this one outside of here because it's 4x plus 10, but that's that top left angle. 108, 3x, and 67. All right, so what should I do with this one?
4x plus 10 plus 108 plus 67 plus 3x is equal to 360.
Yep.
It's exciting.
All right, so we've got 7x plus, go here, 185 equals 360. 7x equals 175. Divide by 7, x equals, what is that, 7 quarters? 25. So x equals 25. Now, if they asked us to actually solve what the angles are rather than just solve for x, we would just take that and plug it back in. But these ones aren't asking us for that. They're just asking us to solve for x.
So it would be like 4 times 25 plus 10.
Yeah. And then 3 times 25 for the other one.
Let's look at like another one.
All right, any questions on that?
No.
Good? Easier than what we've been doing? No proofs? The previous stuff that we were doing. Okay, homework problems. 5 through 21 odd. 25, 27, 29, and then 37 through 45 odd. And again, you do not have to copy the pictures down. You can just look at them. I would say maybe it would be good on like the last few that you're like solving for to do it, just so that you can see the stuff. But if you have the book, that's fine. Just make sure you show your work.
God. Yo, I thought it was first.
You take longer.
Oh, that was
Yes.
the
Can you go
spot
ahead and
right
write his name under yours too?
there. Mr.